Okay, so here we need to explain the concept of finding the angle in between a given line and a given plane. Suppose here a plane is given and a given straight line is given, um, which is intersecting the plane, or yeah, it is intersecting the plane. And so we need to find the angle in between the line and the plane, that is the angle theta. So if the normal vector to the plane is n vector, then if theta is the angle in between the line L1 and the plane pi 1, then the angle in between the normal vector to the plane and the line L1, that will be equal to 90 minus theta. This angle will be 90 minus theta, obviously. So now, therefore, if the equation of the plane pi 1 is given as r vector dot n vector, that is equals to d. So n vector is this, obviously, the normal vector to the plane pi 1. And the equation of the line L1 is given as r vector equals to a vector plus lambda b vector. It means that the line is parallel to some vector b1. So now, therefore, if we take the angle in between the vectors b1 and n1, that will be 90 minus theta. Therefore, cos of 90 degree minus theta, that will be equal to the that will be equal to n cap dot b1 cap, where theta is suppose the angle between the vectors b1 and n1 n vector. Okay, sorry, this is not b1, this is b. uh, or else we can take the equation of the line as a vector plus lambda b1 vector. Okay, so the line is parallel to the vector b1, so then cos 90 minus theta, that will be n cap dot b1 cap. So cos 90 minus theta is sine theta. So sine theta will be equal to n cap, that will be n vector by magnitude of n vector, into b1 cap. It means that will be b1 vector. So it will be the dot product we should take times magnitude of b1 vector. So that would be n vector dot b1 vector divided by magnitude of n vector into magnitude of b1 vector. So this will be sine theta. So therefore, the angle theta in between the lines, sorry, angle theta in between the lines, in between the line L1 and the plane pi 1, and the plane pi 1 is given as theta equal to sine inverse of the magnitude of b1 vector dot n vector divided by b1 magnitude into magnitude of n. So in the Cartesian form, how to find it? So if the equation of the line is given in Cartesian form, if the equation of the plane pi 1 is given in Cartesian form as ax plus by plus cz plus d, that is equal to 0, and the equation of the line L1 is given as x minus x1 by a, that is equals to y, suppose it is a1, then y minus y1 by b1, that is equals to z minus z1 by c1. Then obviously the normal vector to the plane pi 1 will have the direction ratios a, b, and c. Therefore, n vector can be written as ai cap plus bj cap plus ck cap. And the vector b1, which is the vector which is parallel to the line L1, that will be given as a1 I cap plus b1 j cap plus c1 k cap. And the a vector, which is the position vector of the point on the line L1, that will be obviously x1 I cap plus y1 j cap plus z1 k cap. So then, therefore, the required angle, the angle theta between the line L1 and the plane pi 1, and the plane pi 1 is given as the theta equal to sine inverse of b1 dot n. So that would be equal to obviously a1 into a plus b1 into b plus c1 into c divided by the magnitude of b1 into magnitude of n. So that would be square root of a1 square plus b1 square plus c1 square into, that will be square root of a square plus b square plus c square. So in this way, you can find the angle in between the line and the plane. So we can understand this by one solved example. So let's say if it is asked to find the angle, is asked to find the angle between the line, which is x plus 1 by 2, that is equals to y by 3, that is equals to z minus 3 by 6, and the plane which is given as 10x plus 2y minus 11z minus 11z, that is equal to 3. So therefore, let's say this line is the line L1 and this plane is the plane pi 1. So we can convert them into their corresponding vector forms. So the equation of the line is given in the Cartesian form. We can convert it into the vector forms. Therefore, the vector equations of the line L1 and the plane pi 1 are given as, so the vector equation of the line L1, that will be given as r vector equals to a vector, which will be equal to minus I cap plus 3k cap plus lambda into b vector, which is 2 b1 vector, which is 2 I cap plus 3j cap plus 6k cap, and the equation of the plane pi 1, that will be given as r vector dot 10 I cap plus 2j cap minus 11k cap, that will be equal to 3. So therefore, if the equation of the line, if we compare it with r vector equals to a vector plus lambda b1 vector, and if we compare the equation of the plane with r vector dot n vector, that is equals to d, then therefore the b1 vector, which is the vector which is parallel to the line L1, that will be equal to 2 I cap plus 3j cap plus 6k cap, and the normal vector, which is n vector, which is the normal vector to the plane pi 1, that will be equal to 10 I cap plus 2j cap minus 11k cap. So now, since this is the plane pi 1 and this is the line L1, so if theta is the angle in between the line L1 and the plane pi 1, then therefore we know that sine theta, where sine of the angle in between the line and the plane, that is given as the magnitude of b1 dot n1 divided by magnitude of b1 into magnitude of n vector. So now we need to find b1 vector dot n vector. So that would be equal to 2 I cap plus 3j cap plus 6k cap dot with 10 I cap plus 2j cap minus 11k cap. So that would be equal to 20 plus 6 minus 66. So that would be equal to 26 minus 66. So that would be equal to minus 40. And the magnitude of b1 vector, so that would be equal to square root of 2 square plus 3 square plus 6 square. So that would be equal to square root of 4 plus 9 plus 36. So that would be square root of 49, which is equal to 7. And similarly, we need to find the magnitude of n vector. So that would be equal to square root of 10 square plus 2 square plus 11 square. So that would be equal to square root of 100 plus 4 plus 121. So this is 125. So that is square root of 225. Square root of 225 is 15. So now therefore sine theta, where theta is the angle in between the line and the plane. So then sine theta will be equal to the magnitude of b1 dot n vector divided by magnitude of b1 into magnitude of n vector. So that would be equal to magnitude of minus, means mod of minus 40 divided by 7 into 15. So that would be 40 by 7 into 15. So 5 3s are 15, 5 8s are 40. Therefore, the required angle in between the line and the plane would be equal to sine inverse of required angle in between the line and the plane, that would be equal to the sine inverse of 8 by 21. So this is the final answer. Thank you.